Hello everyone, we continue for extra question for MathCore. Okay, for the second handout, the topic is relations and functions. This one I think I will go for the page one only, have 14 questions, and the rest of question we will continue for next term. Okay, so we try to finish the 14 questions. Okay, now we start from the question one. Question one. Now this one is relations and functions. Okay, question one. Question one, we have the given R. Okay, we have R equal to xy, which is belong to R times R. Real number, just say this one. Okay, this means real number. And y equal to 5/2 minus x squared. Then they want to find out the range of R. Okay, that means find the value of y. Okay, I can say R or small r. Then when this one xy, the point xy belong to R times R. R times R, this one real number times real number. That means x belong to real number and y also belong to real number. And this one represents the two dimensions. Okay. So now we start to solve the questions. Because of we know y equal to 5/2 minus x squared. Okay, delay nicer. 5/2 minus x squared. This one is 2, okay. 2 minus x squared. Then you just convert to get the value of x. This is the most easy way to do. Just convert. Move to get the value of x. Say if 2 minus x squared equal to 5/y. And then if we have minus x squared equal to 5y minus 2. So x squared gonna be, this one gonna be 5 minus 2y/y. Then minus gonna be 2y minus 5/y. Then from this case we know y shouldn't be 0, right? Then 5x gonna be plus minus square root of 2y minus 5/y. Ooh. Square root. Okay, when we have this, the value of x plus minus. From this, we know because of we know 2y minus 5/y have to be what? Greater than equal to 0, right? And the y shouldn't be 0. Then from this case, we can get the key numbers of y, right? So y gonna be 0, shouldn't be 0, I mean. And also y gonna be 5/2. Okay, the key number. Then we put testing on the number line. Okay, we can do testing on the number line. Maybe I lay down on up here. Okay. And undo. So we drop out in here. So 0 right here, 5/2. And then 0 to have to be open dot, right? And this one can be included. Y include because have equal sign here, and the y shouldn't be 0. Now we do testing point. So you can test any point which is greater than 5/2. 5/2 is 2.5. So you can try like number 3, right? 3 repeat in here. Repeat in this one. So 3, 2, 6, 3. So come up become plus sign which is greater than 0. Yes. So this one become plus sign. So it's work because I have to get to the equal to 0. Now you can test in the middle between 0 to 5/2. You can try like a x equal to 1, right? Replace in here. Just say this one is a y. Testing them. So replace equal to 1. So come out become replace is 1 to 1 minus. So become negative. Negative gonna greater than 0 or not? No, right? So this one doesn't work. And then this one next should be work. Now we can plot the graph before this one work. Right, so draw a line here and one line here. So light the arrow. So get the answer now. So so the length of R, the final answer gonna be this one. Gonna be negative infinity, 0 open, union close, 5/2 to infinity. Okay, so that's the final answer. So this one's the final answer. Oh. Okay, that is the question 1. Okay. Now we go next questions. Question 2. Question 2. Question 2. As everyone should have handout on hand. Okay, when you see the solution, I will not write all the question on the board. Question 2 say assign A and B are constant value. A and B are constant. Okay. And also they give us function f of x equal to a sine x plus bx cosine x plus x squared, where x belong to real number. Okay. Then if f of 2 equal to 3, then find f negative 2, f of x when x equal to negative 2 equal to what the answer that they want us to do. Now we see the solutions. See the solution. So because of f of x equal to this, so we derive y or f of x equal to a sine x plus bx cosine x plus x squared. Then if f of x when x equal to 2 equal to 3, so you replace x in there equal to 2. So that means f2 here. Replace x with 2, so become a sine x plus b2 cosine 2 plus 2 square, right? Equal to 3. So then we have a sine, or this one can replace at 2. So we have sine 2 plus 2b cosine 2. So this 4 minus 3 become 1, right? Equal to 0. Then from here, I can write it down a sine 2 b cosine 2 equal to negative 1, right? Yeah, can be keep either factor first, either form. Now, after this, we can replace function f of x when x equal to negative 2 in here also. Okay. Then if we have f negative 2, then replace in there. Replace in here. So become a sine negative 2 plus x negative 2 b negative 2 cosine negative 2 and plus negative 2 power 2, correct? We replace in here, okay? This one. Now simplify it, become a, okay, sine negative 2, like a formula in trigonometry, equal to sine minus theta is what? Because what? Sine minus theta equal to minus sine theta, right? And cosine minus theta equal to what? Plus cosine theta. And tan minus theta will equal to minus tan theta. That in the quadrant 4, like the sine in quadrant 4. Okay, so now this one gonna be minus sine 2. And this one gonna be cosine negative 2 become plus cosine 2. So plus minus times minus, and this plus come out become minus, right? So we have 2b cosine 2. And then this one become plus 4. And then you get the common factor negative out from these two terms. So negative out, we have sine 2 plus 2b cosine 2 plus 4. Then we have from here, from this, maybe assign this from equation 1. Equation 1a sine 2 plus 2b cosine, that means this one, right? This one, so become equal to negative 1 plus 4. So become minus become plus, so equal to 5. So we get the answer now. F of x when x equal to negative 2 equal to 5. That's the final answer. Okay. Okay, that's the question 2. Then we go next question. Question number 3. Question 3. If question 3 say assign integer, positive integer, right, as a set, and also say give function a for f of x equal to this one, xy. The function equal to x plus 2y equal to 12, and xy belong to positive integers. Okay, so find the set of value of, so that means they want to find out f of f composite of x equal to something. Okay, so the solution gonna be from this one. Okay, we try to convert to get y first, right? Because we know x plus 2y equal to 12. So 2y gonna be equal to 12 minus x. We can solve right away. So become 12 minus x divided by 2, right? Divided by 2. So we have y equal to this, or this means f of x, right? And because of they want to find f composite of f, they got composite function, right? This one composite function. So then if we have this one f composite of f, we can write at this one, right? Or can write down like a f composite f of x, or you can write down f of x. So many things, same meaning. Okay. So in this one, that means f of x composed to this f of x who here, right? From here. So f composite of f of x, so you compose in here. From this line, okay? You compose in there. So we're gonna have this one. So composite is gonna be 12 minus f of x here. F of x is gonna be 12 minus x, right? So this one gonna be 12 minus x over 2 and over 2 one more time. So equal to here. This one no more here. Okay. So then we simplify this one. One get because f of x here compose in there. Okay. So simplify this one gonna be what? 12. We can divide this one, right? Become 12 over 2 minus 12 minus x over 4, right? Just separate to be two fraction. This 12, this minus this one, 12 over 4. So becomes 6 minus this one gonna be 4, 3 plus, right? Change sign become x over 4. Okay. So this one final gonna be 3 plus x over 4. And because of this one, don't forget the xy, right? Xy, this one have to belong to positive integers. Okay. So from this, we can find the set of these, the set of value of f composite f. That means you find the like a coordinate point f and xy. Okay. From this, we can test from here, say, what x gonna be from here, right? See, it's different color here. From here, you can test if which replace x this one, because they say this one in positive integer. Positive integers mean what? Can be start from 2, right? Positive integer 2, 4, 6, 8, 10, and so on, right? But in this case, we can have only up to where which is equal to 12. Can see this, which is equal to 12. So if equal to 10, see this one. If equal to 10, y gonna be 1, right? So we can try up to, let's see, this one become 8. Now if we test from here, if x equal to 2, if x equal to 2, y gonna be what? 2 become 10, so y become 5, right? You replace 2 in here, paste 2 in here. So become 10, 2, so we got y 5. Now the next, if x equal to 4, do the same way. 4, if x to 4, so 12 times minus 4 become 8, 8 divided by 2 become what? Become 4, right? And so on, continue. If x equal to 6, so 12 minus 6 become 6 divided by 2. If x equal to 6, right, become 6 divided by 2 become 3. And continue. If x equal to 8, 12 minus 8 is 4. 4 divided by 2 become 2. And see next 10, if x equal to 10. So 10, right? With 10 here, so minus become 2. So come out y equal to 1. Okay. So if you go on, say if 12 should be even, right? Because if you can try, if you replace 3, 12, 3, they come out not integer anymore. So this should be even number, correct? The value of x should be even number only, positive even number. Okay, everyone get? Now if you try 14, right? Maybe next 12. So 12 minus 12 becomes 0, over 2 becomes 0. So the next term, this one, when 12 doesn't work anymore, right? Because it becomes 0. Because they need x, y have to belong to positive integer. 0 not positive. And if you try next one, like a 14, it doesn't work either because it's not positive integers. So the value of x, which is we can use it only 2 to 10. Okay. After this, when we know this one, we know the condition of this one. For the value of x can be 2, 4, 6, 8, and 10. But now we have to come back to check with the f composite of f of x. Is work or not, right? When we have this one, we have to check this x. This x belong to positive integer or not? Okay. So we have to work it out. See it's work or not. Now we test from here. This one, right? So if this x is, if you replace x in here, right? Now we test here, okay, by using x. If x equal to 2, replace in here, become a 3 plus 2 over 4. So become integer or not? No, right? Because 1 or 2, this one sum it up is not integer. It doesn't belong to positive integer, so this one doesn't work. So this case, when x equal to 2 doesn't work. Now you type 4. If x equal to 4, if x equal to 4, okay? So you're gonna have 3 plus 4 over 4, right? So become 1, so become 4. So 4 is an integer, positive integer, so this one works. So in this coordinate work, x and y. And you continue testing. If 6, so become 3 plus 6 over 4, right? This one become fraction again because become 3 plus 3 over 2. So become fraction is not integer, it's not positive integer, so this one doesn't work. So that means this case doesn't work. Now continue. If x equal to h, so then you replace, right, 3 plus h over 4, so become 3 plus 2, so become 5. So this is a positive integer, so this one okay, this one good. Now last one, 10. So become 3 plus 10 over 4. Doesn't work either because it becomes fraction. So this one doesn't work. So final answer gonna be this one and this one. Okay. So that's all for question 3. So then the set value of f composite f of x gonna be this two pair, two coordinate point. Okay. Okay, that's a number 3. Now we go on number 4. Question 4. Okay, go on number 4. Question 4. Question 4. Question 4. Question give us two function f of x, which is a real number to real number, and g of x. At the that mean f of x they give also f of x equal to x squared plus 2 absolute x, and g of x equal to x cubed minus 2. They want us to find inverse function of g of x composed with the inverse function f of x when x equal to -1. Want to find what this one equal to. Okay, so now solution we're going to do. We have to, then we know function g of x and f of x. So both of them we have to find the inverse function f of x and inverse function g of x. Okay. Then g of x, right? Because we know this one. Function g of x equal to x cubed minus 2. Then you swap only, right? Just change, just say, change g of x actually is like a y, correct? This one like a y. Okay. You can say it's like a y. So you just change y become x, x become y. So then y become like a x, and x become y minus 2. Then solve for y, because when you get y, that is an inverse function g of x, or function inverse y of x. Okay, then find y out. So y cubed equal to x plus 2, right? Then only y power 1 going to be power 1 over 3, right? Or 1 over cube. So going to be x plus 2 square root cube. Okay. When we have this one, this one equal to inverse g of x already. This is equal to x plus 2 cube. The cube root of x plus 2. Okay. When we have this one, we want to find inverse. This one inverse f of x or no? Oh no. This one they don't want inverse, so we don't change. Don't need this one. For this one, they need only this one. Okay, they want question one. Inverse function g of x composed with the function f of x when x equal to -1. Okay, now we come back to this one. What we have? When we have inverse g of x, now we can get this one now, right? So from here we have g inverse, function inverse g of x, f of x. Okay. So this one compose f of x here. F of x equal to this one, right? F of x equal to this one. So this one composed in here to this one composed in there. Okay. So cube x gonna be x squared plus 2 absolute x plus 2 cube root. Okay. And then from here, because when this one, if we like this one, is the same thing, correct? Same meaning, right? So we have this pattern now, f x equal to -1. So you from here is g inverse f of x when x equal to 1. So replace x with a -1 here. Plus 2 absolute -1 plus 2. Okay. So now absolute 1 come out to plus 1, right? So this one become 1 plus 2 plus 2 become 5 cube. So final answer gonna be 5, the cube root of 5. Okay, that's the answer. That's the final answer, okay? For question 4. Okay, so now continue to question 5. Question 5, question give us f of x equal to 3x plus 1 and f g of x equal to 3x squared minus 6x plus 4. Then they want us to find f g of x. This one, question 1 or 2, 5. Okay. This one means if we realize, you remember we used to learn in limit, like the limit function. We can write in this pattern also, plus g of x. Same meaning. So see the solution. Opposite. Now we have f of x, then we have to try to find g of x. Once if we find out g of x, we get the answer, correct? Now we have to simplify this one in terms of g of x. Okay. Then we start from here because we know f of x equal to 3x plus 1, right? And fg of x equal to this one. Minus 6x plus 4. Then g of x here, we can compose. How to get? Okay, we can compose g of x in there. Okay, from here gonna be 3, because f of x and this, then now x means g of x, so we replace this one in there. So become 3g of x plus 1. Okay, g of x plus 1. After this one, you can see this is a f g of x also. Now we have this one equal, right? This just the equation 1, equation 2. So this equal 1 equal to 2. So we write that become 3x squared minus 6x plus 4 equal to 3g of x plus 1. Then simplify it, gonna be 3x squared minus 6x. Move 1 become plus 3. And then we left g of x here. Okay, so 3 divided every term to this side. So left x squared minus 2x plus 1 equal to g of x. Okay, when we have f of x here, right? See, we have f of x here, and we have g of x, then you replace. And you get the answer. Okay, the answer gonna be x squared plus x plus 2. That's the final answer. Okay, finish question 5. Okay, can take a look one more time. We go next question, number 6. Question 6. Question 6. If f of x equal to 3x squared plus 2 and g of x equal to square root x. Want us to find f times g, f g palm when x equal to 1 plus f g f divided by g palm when x equal to 1 equal to what? Okay, I think I can leave this question for you, let you practice now, because this one not hard. How to do, you just f of x times g of x, just get this equation here times this one. Time it out when you just dip this palm mean differentiate, you know already. After differentiate, you replace x with 1. At the same time, you do dy, right? Get this one, f of x dy g of x. So that means this 3x squared plus 2 divided by square root x. And you simplify it, and then you palm, that means differentiate. Okay, one first derivative only. Okay. And then after you dip this one, replace x with the 1, and then you sum it up, get the final answer. Sum it up. So I tell you the answer key. Question 6. The answer gonna be 12. Okay, 12. Now we go on question 7. Oh, 7, I think similar to question 6. I will let you do by yourself too. Okay, question 7 say f of x equal to x squared plus 5x plus 2. And then g of x equal to x minus 3 over 2. And then they give, say, function h equal to f composite g. Okay. So then they want to find what? Find f palm 5. 1 to 5. So do the same way. You do function f of x times function g of x. That means this, get this one times this one. Time it up, simplify, okay? And then you just dip, this means time, palm, differentiate. After you dip finish, replace x with 5 and then get the answer. So I give you the answer, okay? The answer, this one gonna be 7 over 2. So I let you try do by yourself, okay? That's a number 7. Okay, now we're gonna go for question 8. Continue 8. Question 8. Question say R function R equal to x, y, and this one belong to real number times real number. That's a 2-dimension. This is y equal to x squared minus 4 over 9 minus x squared. Then the question want us to find domain and range of R, function R. Okay, so I think this question really similar to the question 1, right? And can do many ways. You can use find the asymptote, horizontal asymptote, vertical asymptote, and plot graph, and you can get domain and range, the one you used to learn. Another way is like a question number 1. And I have another method also, but I think the easy one do this way. So gonna be do the same way, right? Because we have y equal to x squared minus 4, 9 minus x squared. Then you try to solve it out to get the value of x. Okay? So this one gonna be moved to this side, 9 minus x squared. Oh no, time is up. So become 9y, just cross multiplication. 9y minus y x squared equal to x squared minus 4. Try to get x, okay? So move this one. This one gonna be x squared plus y squared, and this side gonna be 9y minus plus 4. Then get the common factor x out. So gonna be 1 plus y. Get the common factor x squared. So 9y plus 4. Then x squared equal to 9y plus 4 over 1 plus y. So x equal to plus minus square root 9y plus 4 over 1 plus y. Okay, over 1 plus y. Then from this, next one, okay, next step. From this 9 plus 1 mean 9y plus 4 over 1 plus y. Have to be what? Greater than or equal to 0, right? Greater 1 equal to 0. From this, we can get the key numbers. Y is what? Negative 1. And this one gonna be minus 4 over 9. Then we can do testing point. This is a more easy way to do. Testing point. Arrow. Okay. Then negative 1, negative 4 over 9 is about 0.44, I think. 1 gonna be negative 1 here. Minus 4 over 9. Okay, and then we know this one should be open, correct? -1. If -1 is going to be undefined, become 0, so undefined. So this one have to be open dot, and this one going to be back dot, including because have equal sign here, have equal sign. So, and this one we have to test, right? Test the point. You can get replace 0, correct? Get any number or any number greater than -4/9. So we can try 0 here. Replace y with 0. Okay, so become 4/1, which is greater than equal to 0 or not? Yes. So this one works. And then you can try between here also. You can try like a 0.5, right? -0.5. And because this one work and then this one shouldn't work, 99%, there we go, our decoration we learned last year. So this one gonna be work. Okay, now we have this one, draw one line and this side. And so we get the answer now for length of this one, right? So we get location later. Number 5, 6. Length of R, that means got this one. This one, right? Equal to open -infinity, -1. Union close, -1/4/9 to plus infinity. Okay. Then when you get domain, we have this x, right? So when we know y here, how to get for the domain. For the domain, actually, you can see from here, right? Domain should be if you work from here, you can use by we know x, this one shouldn't be 0. Okay, so we have this one shouldn't be 0, right? So we have x squared equal to 9. So x equal to ±3. So this one tell us about what? Vertical asymptote, right? So we get, and the top here, right? You can break it down, become x -2, x +2, right? Also, you can get the key number for this one domain. We have what? +-3 and 2 and -2. Okay, then you can draw the number line and testing point, do the same way. Okay, do the same way. Here, if I draw a number line here. Make longer line. Okay. So then, even okay, no? Okay. Then you can lie down and your testing point, right? Have +-2. -3. We have here -3 +3 here and 2 here, -2 here. Okay. So you have this 4 point here, and then you can test. But we know 3 and negative 3 what should be open, right? Because it's a vertical asymptote. Okay. And then you test the point, do the same way. Okay. Do the same way. So actually, when you test by yourself because we want to, because the timing here, you practice by yourself, testing this one by test from here. Replace any number greater than 3, replace in there. And actually, the domain answer here, kind really clear, right? X should be belong to real number, except what? Except x equal to negative 3 and 3. That's the domain. Okay, and or you can do plot graph also. You can get the domain and range right away. Plot graph, you get the vertical asymptote. That means vertical asymptote here. Horizontal asymptote, how to get this? Divide this way. Horizontal asymptote mean y. Y equal to what? Negative 1, right? And vertical, you have this one. Everyone get? So if you plot graph, remember horizontal asymptote, vertical asymptote. This is a y, right? This is a y. So minus 3 here, 3 here, and this is a vertical asymptote. And vertical asymptote going to be here. This is a y equal to negative 1. This is a x, negative 3. And arrow here. And x equal to 3. And then you plot graph, correct? Plot graph, I think everyone still remember, right? You try by yourself. Can be any way, any method you can try. Okay. Okay, that's a number 8. This question can do 2 or 3 ways. Now we finish number 8. We're gonna go for number 9. Question 9. Question 9. Give us the question say f of x equal to 1 over x and g of x equal to x minus 1 over x. They want to find inverse function f of x composed with the inverse function g of x when x equal to 2. Want to find out. Okay, this one want to find out. So this one again similar to question similar to the question 3, 4, 7, 3, 4, 3, 4, 5, 6, 7, or the compose function. Okay, but you don't need to do the same way. This one like a y, right? And this one like a x. So you change y become x, x become y, and so for y. When you get y, that means you get the inverse function of y. They can say it's a f, right? Inverse. And then do the same way. Swap. This is like a g now. Swap x become g, g become x, and so forth. G. And then you compose and replace x equal to 2 again. You try this question, okay, because it's really similar to the previous questions. And I tell you the answer for this one. The answer for this, okay, equal to negative 1. Okay, so you try to by yourself for this question. Then we go next question 10.